Hello everyone, welcome back to another great section of this wonderful tutorial class. Today we are going to be looking at the topic uniform circular motion and simple harmonic motion. Just introduction to uniform circular motion and simple harmonic motion. Simple harmonic motion. Now, what is the meaning of a uniform circular motion or a circular motion? Now, a circular motion can be termed or described as a motion of the body which describes a circular path. And considering this cycle you are seeing here, let's say we have a body moving in this circular path. So the motion of the body now we call it a uniform circular motion. Now we have this motion will be described in terms of some properties that may be developed from this cycle. For example, now we have the radius of the cycle, we have the angle moved by the cycle, can either be in degree or a radian. Can either be in degree or a radian. Now remember, 360 degrees same thing as 2 pi radian. Then 180 degrees same thing as pi radian. Know that. Then, if we call this x, it's for let's say it's going to move from this starting point A to B with this velocity v. Now, if this x is the linear displacement, this theta here will be the corresponding angular displacement. Remember, we have linear velocity, which is the rate of change of linear displacement. If you change that velocity with time, you have linear velocity. For example, our linear velocity, let me start from angular velocity. Now, angular velocity will be angular displacement over time. Angular displacement over what? Over time. So, we can just say, if theta is a very small angle, for small rho theory, if theta is a very small angle, this linear displacement, which is x, will be approximately equal to r theta. And if you differentiate this side with respect to time, you differentiate x with respect to time, and also differentiate r theta with respect to time, then this arrow will be acting as a constant. We have arrow d theta over dt. Now, look at what I'm trying to say. Change in this angular direction with respect to time, our d theta over dt, same thing as angular. I want to come in a very simple way. So in a very simple way, angular velocity is equal to angular displacement over time. Angular displacement over time. Now, if this angular displacement take a full cycle, that is move one cycle or one complete oscillation, take one complete cycle. Now, if you start from here and move just round to this again, then theta will be 360 degrees. Theta will be 360 degrees. And 360 degrees in radian, because angular velocity is always expressed in radian per second. So 360 degrees in radian will be equal to 360 degrees will be equal to 2 pi in radian. Then over. Now if you complete one oscillation, now the time taken to complete a particular event, or the time taken for a particular event is called period, and we know it by t. So we just take t as period, which is telling you to take or complete one oscillation. So angular velocity will be 2 pi, which is 360 degrees, which is the radian, over the period t, which is time. It's only time on t. And our dx over dt changing linear displacement over time is equal as velocity. So since our velocity is equal to, look at this, since our velocity is equal to change in displacement over time, which is arrow dt over dt, we said dt over dt is angular velocity. We can say linear velocity now will be arrow times angular velocity is what? W. So this one is omega, not W. It's called omega. It's bigger by the omega. So our linear velocity now will be r w. That will be our linear velocity. Then W is the same thing as 2 pi over t. So we can say this one is 2 pi r over t as well. 2 pi r over t. So our linear velocity will be 2 pi r over t or r omega. Then I'm calling W for simplicity sake, so I'm not mentioning it. Then our angular velocity is 2 pi over t. While t can be in this place in terms of angular velocity 2 pi over w. T can also be 2 pi with the period, also be 2 pi over w. And frequency is 1 over period. Frequency is 1 over period, which I express as now w over 2 pi. W over 2 pi, and it's always given in per seconds or hertz. So we also have acceleration of this body. Acceleration of this body, which we call if the body is moving, if the body is like this, it's called that the body is moving around the curved path. Like this. The body is moving around the curved path, and something that may be developed. We are going to have what we call a force, which will be, let's say this body is moving around this curved path. We are going to have a force who will be trying his best to make sure the body don't move away from the curved path. So the force moving the body towards the center of this circular path is what we term as centripetal force. That's what we call it. The force that tends to keep the body moving along the curve. It tends to act on that body towards the center of the circle, so the body will not overturn away from the curve. Then one other one trying to move the body away from the curve path, and that one is called centrifugal force. It's called centrifugal force. So centripetal force and ground force are always equal but opposite in direction. One is trying to act towards the circle, while the other one is trying to act away from the circle. So the centripetal force is equal to give us this centripetal acceleration. The centripetal acceleration of the body moving along this curve now is denoted by A is equals to V squared over R. That's how we denote the centripetal acceleration. Therefore, force is equals to MA. So the centripetal force will now be M V squared over what? Over R. Now, let's denote V, which is our linear velocity. Let's transform it to angular velocity now. Let's look for this acceleration in terms of angular velocity. You see what we are going to have. Now, our A will be, what is V? V is arrow W square over arrow. Now, the arrow square W square over what? Arrow. One arrow cancel this. We are going to have arrow W square. Or you can also say A is equals to W square R. Also have that as your acceleration in this body. Then, if A is equals to arrow square W square arrow, F can therefore be called MA, which is MV square over arrow, or MW squared R. So the force is one. So take note of the relations you are seeing now. Those things are very, very important. Remember theta, angular displacement, x linear displacement, r is the radius of the circle, and the rest, the period, frequency, and so on. Now I can call a question now, and we will solve the question. So take note of the formulas: centripetal acceleration, centripetal force. So this centripetal acceleration, so this and this are the same thing. Terms of linear, but this v is linear velocity or linear speed. This w is angular velocity or angular speed. And r is radius. A is centripetal acceleration, F is force, which is actually centripetal force. Then T is period, F is frequency, this F here, this is like F is frequency, that calculator F is force. Then T is time, then T, then the other calculator T is period, that is angular displacement. Then pi is a radial angle, it's 3.142. So please take note of that. So let's look at some examples now. Alright, let's look at this question. A body of mass 10 kg. A body of mass 10 kg. Body of mass 10 kg. Moving in a circular path. Moving in a circular path of radius 5 meters. Radius 5 meters, and with a velocity of 5 meter per second. Okay, velocity of 5 meter per second. Calculate the acceleration towards the center and the centripetal force on this body. Calculate the acceleration towards the center and the centripetal force on this body. That is the question. The mass is 10 kg. The radius of the circular part is 5 meters. The velocity of the moving body is 5 meters per second. What will be the acceleration towards the center with centripetal acceleration, or the force moving body towards the center with centripetal force? So let's get the business. See what we're going to have here. So centripetal acceleration is either v squared over r or w squared r. So look at this now and look at what was given. V was given, W was not given. So this is really best to use. So that would be V, which is 5 squared over 5 as well. 1 5 will cancel 1. You have 5 meter per second squared. Let me just say that. See, one thing about physics is that there are no questions. You don't know if you just know the relation and what the question is talking about. You are ready to go. Let's go to the next one. Centripetal force is equal to mv squared over r or mw squared r. So which one will work out? No w in this question or v here. We're going to use this one. Use m is 10 times v. What about v? V is 5 squared over 5. Or m is 10. You can go to m. You can multiply and get the answer. They'll give us, cancel this, was 50 newtons. The centripetal force will be 50 newtons. So let's look at this next question. Look at this question 2. An object of mass 50 grams. An object of mass 50 grams moves along a circular path of radius 10 cm. Moves along a circular path of radius 10 cm with an angular velocity of 2 radian per second. Of 2 radian, this is just abbreviation of radian. Of 2 radian per second. 2 radian per what? Per second. Obtain the speed, that's linear speed. Obtain the speed of the body. Obtain the speed of the body. The centripetal acceleration. Centripetal acceleration of the body. Centripetal acceleration of the body. And the kinetic energy of this body. Kinetic energy of this body. And the period t. And the period t. And the period is what the t. So how will we run through this question now? So let's learn one after the other. The first one is say we should complete what? This one is start this one, start this. That's number I, this, number I, this, I, this, IV, this. Number 1, 2. That's what we do by style. Style is not part of the question. Take note of that. Because yeah, what's style A again? Style is just the new thing. Let's have number I, this one, then the I, this, then number 3, then this, then IV, this one. That's what I mean by style. So what is our I, V is what? Arrow double. Arrow times double. Now what's R? Or W is omega is 2 radian per second. Then our arrow is 10 cm, using that 10 over 100, 0.1 meter. When you go back from cm to meter, you divide by 100. That's how you go back to the right unit. Moving to meters, that is the one you use. The rest, our V will automatically be equal to, R is 0.1 times 2. That will give us 0.2 meter per second. That's what we have. Then, question 2, centripetal acceleration. It's centripetal acceleration. That is A is equal to V squared arrow, or I just say W squared R. Anyone is possible because we know our V here, then W was given the question. So use anyone you like. So I'll use the 2 now. This is what I do. I'll play this one first. I'll give us 0.2 squared over 0.1. That'll be 0.2 times 0.2 divided by 0.1. 0.1. And that'll be 0.1 divided this one. We are going to have 2 there. We will have 2 there. So everything here will give us, this one will give us 0.04. So we are going to have 0.2. This one divided by 0.1 will give us 2. That will give us 0.4 meter per second squared. But we can try to use this one. Is A is equal to R squared W. What's W? 2 squared times 0.1. That will be 4 times 0.1. That will be 0.4 meter per second squared. I'll also give you that. Then let's look at the third question there, which is the kinetic energy of the body. Kinetic energy of the body. Kinetic energy of the body. So we have KE from our last class. We have KE. Kinetic energy is equal to half times mass times velocity squared. That's mv squared. Half mv squared. So what is the mass of the body? The mass is 50 grams. That is the mass. So can we use gram? No, we are going to use kilogram. We're going to use kilogram. So right from gram to kilogram, we have to divide by 1000. Divide by 1000, we're going to have 0.05 kilogram. So we will have as the mass. So the kinetic energy now will be equal to 1 over 2 times 0.05 times 0.2 squared. 0.2 squared. 0.2 squared. So I'm going to convert it to decimal so that we can solve it clearly. It will be very lovely. It will be very lovely. So I'm going to have something like this. This one is 0.5. And you can solve it with your calculator or get the answer. But I don't want to use calculator, you have to use try and solve it just like this. Times 0.05 times 0.2. Another 0.2 will be 0.2 squared. So let me go into the decimal and I have 1, 2, 3, 4, 5. That's what I have it. So I have it here. So that will be 5 times 5 times 2 times 2 times 10 raised to power is 1, 2, 3, 4, 5. 3 minus 5. Now it was 5 times 5, 25, times 2, 50, times 2 again, 100. Now 100 times 10 minus 5. That's empty as 1.0, 1.12, times 10 to the power minus 3 joules. I really can take energy. 1.0 times 10 to the power minus 3 joules. But you need to be doing it this way. I just want to solve it. So we are free to just use calculator 0.5 times 0. I just do half times 0.05 times 0.2 square. You get this one directly. No need to be solving it like that. We want to do it in the exam condition. Then the time, the period T. Period T. What will be the period T? That period is equal to 2 pi over W. That is 2 pi over 2. Some cancel this. Where we 5 seconds, or pi is approximately equal to 3.14 seconds. So this will be the period of motion T. So please study this question very well, and please, if you have any question, you are free to go back, watch it over and over again. Now, I want to look at the second aspect of this one, which is the simple harmonic motion. Alright, simple harmonic motion. Now, simple harmonic motion simply is a periodic motion of a body or of an object which repeats itself at equal time interval. Now, I just did introduction to this topic, and we are going to look at this question or this diagram which shows the pendulum ball swinging that describe a simple harmonic motion. This is a type of simple harmonic motion. Now, if you raise this pendulum to this place, now this is a thread holding the pendulum ball to the fixed point, which is like a ceiling or any point that you hold it, or it's a clamp. And if you leave it, it's going to be swinging at equal time interval. So this swinging motion of this pendulum ball, or the periodic motion of this pendulum ball, is described what we call a simple harmonic motion. This is one type of simple harmonic motion, and you may be asked to calculate the velocity at which this ball is moving in this harmonic motion, the acceleration, and the others. So, take note of this. At this end, okay, let me label it. Let's call it O, A, B. At A and B, the body will not be moving. A and B, the body will stop. So the velocity at A and B will be 0. So velocity at A and B, it will stop here, it will move back, stop here, back, stop here. So at maximum, this one is the displacement of this ball, the ball. So this maximum displacement you can give this ball, call it amplitude. So this is the amplitude of the motion. This maximum displacement you are giving the ball. And at the center, you are going to have your maximum velocity. This is the center of the oscillation. The center of oscillation. You will have the maximum velocity at that center, and at each end, the velocity will be 0. And you're still going to have the acceleration at this end. This is the angular velocity, the W squared times the displacement you have. Acceleration at this point will be the W squared times the distance between this place and this place, and so on. Now, you can also ask you to look for the velocity at any distance, or what is the velocity of the ball at this point, or at this point, or any point, any distance. Let's call the distance. Let me use y to denote that distance. So the velocity at any distance y from the center of the circle. So the velocity of any distance y from the center of the circle given by w square root of a squared minus y squared. Y is the distance or any distance from the center of oscillation. Any distance of the experiment from the center of oscillation. For A is the amplitude, is one distance of the experiment we're looking at now. Then W is the angular velocity. Then the maximum velocity now will occur at the center of oscillation, in which y will be 0. It will not be y. Then you have W times the amplitude, which is A, or the R. Then, if it's equal to R, which is radius, if it's equal to radius, it will be W times radius. Then, what about the acceleration of the body? Acceleration of the body is the same thing as W arrow or WY. Acceleration will be equal to W squared Y. That will give us the acceleration. So acceleration at this point now is when Y is equal to A. Take note of that. If you say what is the acceleration at this point A, Y will be equal to A. What is the acceleration at this point? Y will be given. What is the acceleration at the center and so on. Check at the center now. Body is accelerating. Y will be 0. Center. So you can see denote this one as W squared and the acceleration at any distance r. When y is 0, it will also be 0. When y is maximum, it will also be maximum. So take note of that. It's very, very, very important. So let's look at this question before we go. A simple pendulum ball of mass 10 grams. A simple pendulum ball of mass 10 grams is vibrating up and down. So everything up and down in simple harmonic motion. It's vibrating up and down in simple harmonic motion with amplitude of 4 cm. With amplitude of 4 cm. With amplitude of 4 cm. And a period of 2 seconds. And a period of 2 seconds. First question. Calculate the velocity at the center of oscillation. Calculate the velocity at the center of oscillation. That is when y is 0. Like this. Okay, what will be the velocity at the center? That is the maximum velocity that you have. Then, calculate the velocity and acceleration. Calculate the velocity and acceleration at the point 1 cm from the center. Calculate the velocity and acceleration at 1 cm from the center. Then number 3, what will be the kinetic energy? What will be the kinetic energy at the center of oscillation? What will be the kinetic energy at the center of oscillation? So let's look at this to see what we will have. Know that maximum velocity is equals to w times what? Speed. Our a is equals to 4 cm, which is 4 over 100, 0.04 meters. Then w was not given, but w is equals to 2 pi over t. Is equal to 2 pi over 2, that is pi radian per seconds. That is w. So our v maximum now will be w, which is pi times 0.04. So that's going to give us 0.13 meter per second. We're going to have 0.04 pi or 0.13 meter per second. So that's what we're going to have. Then approximately. Then for the next question, what will be velocity at the distance of 1 cm from the center? What will be w times a squared minus y squared. That is when y is 1 cm. That's what I tell you. So when y is 1 cm. 1 cm from the center. You say 1 cm from the center. That is divided by 1.01 meter. That's what I do now. So the velocity at that y is equal to 1 cm will be v is equals to pi times square root of 0.04 squared minus 0.01 squared. So if you do this very well, you go to 0.12 seconds. So we have. The next, what will be the acceleration at 1 cm from the center? So the acceleration will be w squared times the distance, which is from the center. That will be pi squared times 0.01 I squared times 0.01. So if you do that, what are you going to have? You do that very well. You have approximately 0.1 meter per second squared. So you have 0.1 meter per second squared. Approximately. Then, third one is what the kinetic energy at the center as half mv squared. So what is saying? The mass is 10 grams divided by 1000. We're going to have 0.01 kilogram. So we will have half times 0.01 times 0.13 squared. So if you solve this very well, you are going to have 8.5 times 10 to the minus 5 joules. That's what you are going to have. So please look at this what's it called topic very well again. Both the uniform circular motion and simple harmonic motion. Look at it very well. And please ensure you practice this over and over again. You can watch the video over and over again. If you have any questions, you can drop it in the comment section. And please ensure you always avoid distraction when you are in our online class. So God bless you all.